You know, sometimes the biggest industrial revolutions are hidden in plain sight. Today, we're talking about one of those, and it's happening right on the skin of one of the most common airplanes in the world, the Airbus A320. This is a story about a battle between a 20th century chemical art and a 21st century robotic science.
Right, that's the big question, isn't it? Every single kilogram you can save on an airplane means less fuel and more efficiency over its entire lifetime. So, we're going to focus on just one part, a huge panel from the A320's fuselage. To make it lighter, you have to carve material out of it. But, and this is a big but, you have to do it with just unbelievable precision, or the whole thing could fail.
For decades, the undisputed champ of this process was something called chemical milling. I mean, it's this really ingenious, almost alchemical technique that was born back in the mid 20th century. And it was absolutely perfect for the big, relatively simple aluminum skins you'd find on planes like the A320 or the Boeing 737.
So how does this old school method actually work? Well, it's kind of like a multi-stage dance of chemistry and a whole lot of manual labor. The best way to think about it is a super controlled dip and dry. First, you apply this protective mask to the whole panel. Then you carefully cut away a pattern. And then you dunk the entire thing into a giant vat of acid. The acid just eats away at the exposed metal, creating these thinner pockets to save weight.
And this is the result. On average, you remove 48.5 kilograms of aluminum from just one of those A320 side panels. I mean, that's a huge weight saving. It's like taking a small child off the plane. It's a pretty remarkable feat of engineering for sure, but it turns out this weight reduction comes with some very, very heavy baggage. Yeah, the old way is really starting to show its age. For starters, it's messy. It creates tons of hazardous sludge that's incredibly expensive to dispose of. It's also really slow. We're talking up to 36 hours for just one panel. And what's really crucial here is that it can be imprecise. In fact, just a few years ago, tiny variations in thickness from this exact process led to a massive quality crisis that affected over 600 Airbus jets, a very costly problem. But a challenger has officially entered the ring, and it's a high-tech, precise, data-driven solution from a company called M-Torres. And it's all about replacing that big vat of acid with a team of hyper-accurate robots. Okay, now what's really amazing about this new tech is what they call its superpower, the Universal Holding Fixture, or UHF. You see, instead of building these massive custom steel frames to hold every single different panel shape, this is a smart, flexible bed of robotic actuators. It can literally conform to the exact 3D shape of any panel you put on it, all in a matter of seconds. This one innovation is what makes high-precision robotic carving both possible and really cost-effective. And the workflow? Well, it's a whole other world compared to the chemical bath. A single person loads the panel onto that smart fixture. Then a giant robotic gantry just gets to work, carving away material with a super high-speed cutting tool. But here's the genius part. It measures the thickness of the skin in real time as it's cutting. This guarantees a perfect result every single time and totally eliminates that old risk of having to scrap the whole expensive part. All right, so we've met the two contenders. We've seen the old way and the new way. Now, let's put them head to head. Using some pretty recent production data, we can see who really wins this battle for the skin of the A320. Let's start with that 48.5 kilograms of aluminum that gets removed. With chemical milling, it's dissolved into toxic sludge. It's a pure liability, something you have to pay a lot of money to get rid of. With mechanical milling, that same aluminum is turned into clean, dry chips that are 100% recyclable. You actually sell this supposed waste back to smelters. You turn a cost into a revenue stream. It's an incredible difference. Okay, now let's talk about speed. The old acid bath process takes, on average, 32 hours from start to finish. The new robotic milling process, just 5.5 hours. That is a staggering 75% reduction in the time it takes to make one panel. That's an absolute game changer when you're trying to build, say, 75 airplanes a month. But, you know, it always comes down to the bottom line, right? So just look at these numbers. Direct labor costs, they plummet. The cost of things like acid and masks gets slashed. Hazardous waste disposal costs, they're completely gone. Zero. And then you get that little bonus, that credit for the recycled material. So the net cost drops from over $4,800 all the way down to just over $1,000. So here it is. This is the crucial point.
For every single panel that gets made, the new robotic method saves $3,778. Now, multiply that by the thousands and thousands of panels needed to meet production targets, and you can see why this isn't just a small improvement. It is a full-blown revolution. And this is about way more than just saving money on one little part. This shift really represents a fundamental change in how we think about manufacturing. We're moving away from an imprecise, wasteful art form and towards a clean, precise, data-driven science. So the drivers pushing this change forward are pretty undeniable. First, you've got the big environmental goals. Manufacturers are in a race to get rid of hazardous waste. Second, quality control. That digital twin created by the robot process guarantees every panel is perfect, which prevents those costly errors from the past. And finally, you just need pure speed and automation to build planes faster than ever before. You know, this quote really just says it all. The old method was a product of its time. It was a brilliant solution for the planes of the 20th century. But for the highly optimized, high-rate production lines of today and tomorrow, the future is clearly being milled by robots. So the next time you see an A320 at the airport, you'll know the secret story that's hidden right there in its skin. It's a story of innovation and efficiency and sustainability. And really, it leaves all of us with a question. What's the slow, wasteful, imprecise acid bath process in your industry, or maybe even in your own job, that's just waiting for its moment of robotic disruption?